Alright, here's section 2.2. We're going to learn the basics of solving one-step equations. This is going to be a matter of undoing whatever's happened to the equation. So first we'll go through some vocabs and then do some examples. First vocab, solve an equation. So when the directions to a problem say solve an equation, what does that mean? It means the act of manipulating the equation to find the solution. So the act of manipulating an equation is going to be basically the golden rule, which is the next vocab word down here. So first copy that one down. To solve an equation is to manipulate the equation to find a solution. So what about equivalent solutions? Equivalent equations, mind you. These are going to be two equations that have the same solution. So in the act of manipulating the equation, each time you simplify it, you come up with an equivalent equation. It's very important that they are equivalent because they have to have the same answer. You don't want the act of solving it to change the answer, obviously. So as you simplify it, you're creating numerous equivalent equations that are simpler and simpler and simpler until at the end you have the final solution. So this act of manipulating, what is it that you're actually doing? You're following the golden rule of math. So the golden rule of math is something that you must always follow when you're solving equations, and it is whatever you do to one side of an equation, you must also do to the other. The idea here is if you have something which is balanced, and you have something here, and you have something here, if these two things are balanced, as long as you manipulate both sides in the same way, the equation will stay balanced, and this side will still be equal to this side. But if you do different things on the left and the right, then of course they'll become unbalanced and no longer equal. So there's a lot of things you can do. You can add to both sides, you can subtract from both sides, you can multiply both sides, you can divide both sides. Those are your basic four operations. And as you go through math into high school and even college, you'll learn more and more techniques or things that you can do to both sides of an equation to help you solve more and more complex equations. But even when you're in advanced calculus 3, you're still following this golden rule. Whatever you do to one side, you also do to the other. Alright, so problem solving tips. What do we do when we have a problem? How do we know what to do or what steps to follow? So we have to ask ourselves, what's happening to my variable, and how do I undo it? Because I'm trying to work backwards to recover that unknown value. So you always want to work backwards and do the opposite of whatever is happening. So the way that you can do that if it's division or multiplication is to remember that multiplying by the reciprocal is the same as dividing, and often, as you'll see in some examples, is a much better way of writing it and solving it. The last thing I want to comment before we do some examples is you always want to check your answer and see if it makes sense. When you're solving an equation, you get an answer, you can plug that answer back into the original equation, and it should work. It should be reasonable. So you can do that. Here we go. Let's do some examples. One-step equations. So all these equations can be solved with just one step. So we might have something like 3x equals 12. So the solution is to do some math operation to both sides to get x by itself. So we look at what's happening to the x. Currently x is being multiplied by 3. To undo that, or do the opposite of that, we could divide both sides by 3. 3 divided by 3 cancels out. So on this side we just have x. On this side 12 divided by 3 is 4. That's our answer. Now we can plug it back in and make sure it's reasonable. 3 times 4 is 12. Yes, that worked. It makes sense. We're good to move on. What about 4/5 of x equals 10? Okay, if you have something like this. Now, again, the x is being multiplied by 4/5, similar to this one, but instead of dividing by 4/5, because then if you divide by a fraction, that's kind of annoying, you can multiply by the reciprocal. And really, it's the same thing. You remember that we learned a long time ago in previous math classes, dividing by a fraction is the same as multiplying by the reciprocal. Okay, so the 5's cancel out, the 4's cancel out, and we're left with just x. So 5/4 of 10 is 50/4, or you could reduce the 10 and the 4 to be a 5 and a 2. So 5 times 5 is 25. 25/2, which if you want, you could do 12.5. So you could leave it as a fraction, or you could write it as a decimal if the decimal is a nice terminating decimal. If it was infinitely repeating decimal, then you want to leave it as a fraction. Okay. So these are problems where you're going to multiply or divide to undo it. You could also have something like this. X plus 4 equals, I don't know, 13. Okay, what's happening to my x value? My unknown value is having 4 added to it. To undo that, you do the opposite. which is subtract 4. If I subtract 4 on this side, I have to subtract 4 on this side to keep them balanced. The 4's, positive 4 and negative 4, cancel out. And we've got x equals 13 minus 4, which is 9. And you can always plug the 9, plug this answer. You don't have to physically write it out, but in your head you can plug this back in right here and make sure that it's reasonable. So 9 plus 4 equals 13. It looks good. Last one, let's go. I'll do 2 more. X minus 2 equals negative 15. Okay, the x is having a 2 subtracted from it, so we want to add 2. Add 2. Cancel those out. Negative 15 plus 2 is negative 13. You need to be excellent at adding and subtracting integers to be successful in this class. And the last one I want to do is, because it comes up a lot in problems, say you have negative x equals 11. Okay, how do you get x by itself? Well, this is really negative 1 times x. So you could divide both sides by negative 1. This is an equal sign here, not a negative. Or you could multiply both sides by negative 1. In both cases, whether you multiply or divide by negative 1, it will cancel out the negative sign, which gives us x equals 11 divided by negative 1, or 11 times negative 1 gives us negative 11. So basically, you're kind of moving the minus sign from one side over to the other. This is a great final step, and once you get comfortable, you can just go from here to here without actually showing your work. Alright, that's it for one-step equations. Find out what's happening to it, do the opposite, and double check your answer, and you're good to go.